Vegetable oils and animal fats are naturally occurring lipids in plants or animals. Oils and fats are often in the form of triglycerides, which are formed from a molecule of glycerol and 3 fatty acids. A fatty acid is a weak carboxylic acid with a hydrocarbon chain as the functional group. In a triglyceride, the 3 fatty acids are linked to the molecule of glycerol by ester bonds. A triglyceride, therefore, has 3 ester groups, making the molecule a triester. An ester is a type of organic molecule that is like a carboxylic acid with the hydrogen of the hydroxyl replaced by an alkyl or aryl group. This group is labeled R' to show that it may be different from the R group on the other side. In a triglyceride, R' is the glycerol backbone, and each R group is the chain of a fatty acid. Fatty acids with double bonds in their carbon chains are known as unsaturated fatty acids. These double bonds tend to be in the cis conformation, which puts a bend in the chain. Triglycerides with these bent chains can't fit closely together, so the attractive forces between them are typically long-range and weak. Fatty acids with only single bonds between the carbon atoms are saturated. These unbent chains allow triglycerides to pack closely together, enabling stronger, short-range intermolecular interactions. This gives saturated triglycerides a higher melting point than unsaturated triglycerides, which are usually liquid at room temperature. Triglycerides can be converted back to fatty acids and glycerol by hydrolyzing the 3 esters. Ester hydrolysis is a reaction that breaks an ester bond with a molecule of water or a hydroxide ion to form a carboxylic acid and an alcohol. One common use of ester hydrolysis is to create soaps, which are the salts of fatty acids, from triglycerides. This process is called saponification. In this reaction, hydroxide ions attack each of the 3 ester carbonyls in the triglyceride, yielding 3 fatty acid molecules and 1 molecule of glycerol. The fatty acid carboxylates associate with the counterion from the base, which is usually sodium or potassium. But how does soap work? The long carbon chain is lipophilic and hydrophobic, meaning that it is attracted to fats but not to water. The carboxylate group is hydrophilic, meaning that it is attracted to water. When you mix soap and water, the long carbon chains tend to interact with each other and avoid interaction with water molecules, while the carboxylate groups prefer to interact with water. Ultimately, the soap molecules form clusters called micelles, with the hydrophilic carboxylates facing outward. Now, let's assume there is hydrophobic grease on your hands. Simply rinsing your hands with water would not remove the grease. When you wash with soap, the grease interacts with the soap's carbon chains. As the soap molecules form micelles, they bring the grease into the hydrophobic core, enclosing it in a hydrophilic shell that can then be rinsed away with water. In this lab, you will perform a saponification reaction to create soap from coconut oil and sodium hydroxide. You will then test the tolerance of your soap for hard water by comparing the foaming ability in deionized water, tap water, and a calcium chloride solution, which mimics extremely hard water.